Okay, then, so expected value. Really, really important concept in poker. In fact, of all the concepts, it's probably the most important. And in fact, it's pretty important in, all gambling. In fact, it's pretty much the core of all gambling. And all these other things actually in life, like insurance is to do with expected value, banking is to do with expected value. So it's a really important concept, and it's worth knowing, even if you don't play poker. But if you do play poker, you have to know it. I think most poker players have a pretty good intuitive understanding of how expected value works, because they sort of felt it. They felt, in the long run, when you get kings, you don't always win. Sometimes you win big, but in the long run, you sort of win with this hand. So, you just feel it because you get kings, and you're like, yes. And you know that because you just saw it. It wins in the long run. And this is where this definition that I've sort of written down, expected value is basically expected return on investment in the long run. So it's what you could expect to win if you sort of did this situation again and again and again and again for like an infinite number of trials. This is what you'd sort of expect your average winnings to be. And I could do a sort of technical proof with limits and whatnot, but this doesn't. I think most people get this idea. And that definition I've laid out in blue. Okay, so let's just do an example, and I'm going to do the example everyone has seen. Okay, so here we've got the classic coin toss arrangement. We've got heads and tails. If it lands on heads, you win $1, and if it lands on tails, you lose $1. And most people sort of get the intuition here, in the long run you can expect to win nothing. But let's just do the sort of maths behind it. So let's just say expected value V equals the probability of heads, okay, times by the reward of heads. So let's call it 1 plus the probability of landing on tails times by the reward of tails, which is -1. Okay, so, the probability of heads equals 1/2, and the probability of tails equals 1/2. So, just sticking the numbers in. My probability of landing on heads is 1/2, so it's going to be 0.5 times by 1 plus probability of tails, which is 0.5 times by -1. So that's 0.5 minus 0.5, which equals 0. So hopefully you get the intuition for that. I think most poker players get the intuition of expected value, but I don't think so many of them get this sort of technical maths behind it. Okay, so the probability, this term here, sort of get around, this term's to do with when it lands on heads, and this term here is to do with when it lands on tails. It takes, what's the probability of landing on heads, and then times it by the reward. So if you were to try and make it so that it was positive expectation for you in this game, what you do is you try and manipulate one of these, anything in these terms. So let's say the probability, if you increase the probability of it landing on heads, then it would make it plus EV, because this term here would get bigger, so this positive number here would get bigger, and actually this term here would also get smaller, because if it lands on heads more often, it's going to land on tails less often. Okay. And another thing you could do is you could change the rewards. You could say, all right, well, to make it plus EV, let's just make it so that, you win $2 instead. Okay? Now, let's just do a slightly more complicated example. Let's suppose now that we have a crazy world where we have a 4-sided die. Okay, so I just quickly wrote down the data for our 4-sided die, crazy world. And here are our rewards, okay? If it lands on 1, we get 0. If it lands on 2, we get 1. If it lands on 3, we get -1. And if it lands on 4, we get 0. And the probability of it landing on 1 is 1/2, the probability of it landing on 2 is 1/4, and the probability of it landing on 3 is 1/5, and the probability of landing on 1/4, probability of landing on 4 is 1/20. And you should note here that the probability of 1, 2, 3, and 4 is equal to 1, because obviously it has to land on one of these if we're going to throw a dice, which doesn't exist in the real world, a 4-sided dice, as far as I can think of. So what is our expected value here? Well, it's not immediately obvious, is it? And we can't use our sort of poker player's intuition that we did before. It's like, let's just break even. And now we're going to have to think, okay, well, we have to try and do a little bit of maths. So let's just try and do what we did last time with the coin and just break it down into its little component parts. So expected value equals, well, let's just deal with landing on a 1 first. Well, it's the probability of landing on a 1 times by the reward, which is 0. Okay, plus the probability of it landing on a 2, and the reward of that, which is 1. We'll just go through it. So probability of landing on a 3 times by its reward, which is -1, plus the probability of 4 times by the reward, which is 0. Now then, we can just do a few quick simplifications here, or we can reduce it down, because here we can see, alright, well, probability of 1, which is 1/2, times by the reward, which is 0. So we can actually just cancel that term out, because anything times by 0 is 0, 5 times 0 equals 0, 100 times 0 equals 0. I don't want to insult some people's intelligence, but it might not just be immediately obvious the way I've written it out there. So you can just cross this term out, it just equals 0. And you can do the same thing here for the probability of 4 times by 0. No, it's just 0, so cancel that out. So we've reduced our formula down to this. Probability of 2 times by 1 plus the probability of 3 times by -1. So if we stick the fractions in that we have our probabilities in, well, our EV, well, what's the probability of 2? Well, that's 1/4 times by 1 plus probability of 3, which is 1/5, times by -1. And that equals 1/20th. Gone crazy. So our EV in this particular case is positive, and it's 1/20th. I know it could be units of anything, could be dollars, could be bunkies. Okay, but you get it. So I hope you get it. So we use the equation to reduce it down and work out what our expected value is, and our expected value here is positive, so we should take this gamble. Okay then, now I just want to write out a more general expression now, just for expected value, because we've done a few examples, and I just want to get the algebra kind of way. So, we can say expected value, and hopefully this intuition works now that I've shown you the examples, and you get how it works. The probability of the first event, so we'll just call this 1 times by the reward of event 1, okay, plus the probability of event 2 times by a reward of event 2, okay. Just do different colours and whatnot, just to lay it out so you can see the bits. So basically, the EV equation is just a bitty one, kind of really. It just sort of, in fact, it never ends. Okay, times the probability of the third event times by the reward of the third event. And in fact, this just goes on forever. That formula doesn't actually stop in theory. We could just add as many possible events as, ever. We could say, all right, well, picking out a human being and what their nationality is, and you get a reward if you pick out a certain nationality. Well, I don't know how many countries there are in the world, but you can imagine there's an awful lot, and each one of those nationalities needs its own little term, and it needs its own little rewards. So hopefully that explains sort of, I think most people get the intuition behind the expected value, and hopefully that explains some of the maths behind it.